In this video, we are going to look at the methods that we can use to show that a quadrilateral is a parallelogram. This will involve sometimes writing a two-column proof to prove that you have a parallelogram or to prove something is true. Sometimes you'll be given a parallelogram and have to prove something about the image. Sometimes our goal will be just to prove that a figure is a parallelogram. There are 5 methods that you can use in order to prove that you have a parallelogram. Method number 1 is to show that both pairs of opposite sides are parallel. This will prove that you have a parallelogram, and the way I would write this in a proof is to write what is highlighted here in green. If both pairs of opposite sides are parallel, then parallelogram. The second option is to prove that both pairs of opposite sides are congruent. So if you're able to do that, then you can say that you have a parallelogram. If we were doing this with coordinates, we would be using the distance formula 4 times. If we were proving the first method with coordinates, we would be doing the slope formula 4 times. For number 3, you are able to prove that you have a parallelogram if you are able to prove that both pairs of opposite angles are congruent to each other. This would not necessarily be one that we would do with coordinates because we would only be able to prove that we had right angles if we had a coordinate grid for this one, and that would be kind of rare. The fourth option is to prove that one pair of opposite sides is congruent and parallel. Has to be the same pair of sides being both congruent and parallel. And if this is true, then you have a parallelogram. And then the fifth option, and I feel like if you have coordinate points and you're trying to prove that it's a parallelogram, this is the least amount of work that you have to do. And that is to show that the diagonals bisect each other. If you were trying to do this one with coordinates, you would just do the midpoint formula 2 times, and if it's the same point for each of the times that you're doing that midpoint formula, that would prove to you that the diagonals are in fact bisecting each other and that you have a parallelogram. So we're going to use these reasons. Sometimes they're going to give us a picture, or they might give us a description and things that they know they're telling us are congruent to each other. And you might just be having to say, which reason are you using? Sometimes they're going to give you 4 points and they're going to ask you to use formulas to determine if it's a parallelogram or not. And those formulas would be the slope formula, the distance formula, and the midpoint formula. Then sometimes we'll have a 2-column proof where you might be using congruent triangles and corresponding pieces and maybe even using like alternate interior angles to prove that your lines are parallel and that sort of thing. So can have several different types of questions involving these 5 ways to prove that you have a parallelogram. So let's look at some of them. These would be the most basic ones where they are giving you a picture and they have some things labeled in there and they're just asking, what theorem could you use to show that you have a parallelogram? On number 1, we know that a quadrilateral, the sum of the angles of a triangle, we know triangles add to 180, and we should remember that quadrilaterals have a sum of 360 degrees. So we can use the fact that a quadrilateral should add to 360 degrees to find our missing angle on number 1. If we do that, we should get a remaining amount of 75 degrees. And this allows us to see that our opposite angles are in fact congruent to each other. Now you have to phrase this very carefully. You have to use the word both. If both pairs of opposite angles are congruent, then parallelogram. And we use just the little drawing of a parallelogram to represent the word parallelogram, and I always use that because it is an accepted thing that we use in geometry, and I don't like to write the word parallelogram. It's a very long word to write. On question 2, you can see that the opposite sides are labeled, and we can notice that they are equal to each other. So we would say if both pairs of opposite sides congruent, then parallelogram. So we're using both pairs of opposite sides congruent in order to show that. If you write this reason and you forget to put both in there, it would be marked incorrect. So be sure that you are very carefully wording your reasons. Here we have pieces of the diagonals labeled, and they are labeled congruent to each other. This means that the diagonals are bisecting each other. So you would say if diagonals bisect each other, then parallelogram. On number 4, we can see that the side over here is labeled with a 10 and on the left as well. And they both have those parallel markings. So this gives us one set of opposite sides that is both congruent and parallel. So if one pair of opposite sides congruent and parallel, then parallelogram. So let's see. Trying to think. The only one of the 5 reasons we did not use is if both pairs of opposite sides are parallel, then parallelogram. So let's continue. Here is something that they like to do. They like to just say, for what value of x would make it a parallelogram. And in that case, you just act like it's a parallelogram. And what would you do? Well, if it was a parallelogram, they label the pieces of the diagonal. Then I would set those pieces equal to each other. And then I would solve. And, pretty easy one there, just getting x equals 6. On the right, on number 6 there, if it was a parallelogram, then they are labeling some consecutive angles. And we should know that consecutive angles are going to be adding to 180. So if this was going to be a parallelogram, then I would add these angles together equal to 180 degrees. Doing some combining like terms, we get 6x minus 6 equals 180. Adding 6 to isolate the x variable here, and dividing by 6. I'm getting 31 for my x value. So just pretty much act like it's a parallelogram, and what would you do? Here are some coordinate proofs where we are wanting to show, that it is a parallelogram using some formulas like slope formula or distance formula. We want you to show work for these on these. I did give you a graph just to kind of help us out in our thought process, but there will be times that we will ask you to do this without graphing the figure. And so that means we want you to start with like formulas like distance formula and slope formula, and kind of work your way through them to see what kind of shape it is. But we're just going to start by demonstrating graphing one on a coordinate grid here, a really basic question. A is at -2, -3. B is at 0, 5. C is at 6, 5. And D is at 4, -3. So if I connect my dots here, all right, we can kind of tell when it's on a graph grid like this. If you have a horizontal line or a vertical line, you could pretty much get the measurement of the slope and the measurement of the length by just counting. So I wanted to demonstrate with that here. The easiest way to prove that this is a parallelogram, if we were able to see it on a graph, is to notice that this would have a slope of 0, and so would this one. And we can also count, so I would say that BC slope is 0, and that AD slope is 0. And I can count the length of BC, 1, 2, 3, 4, 5, 6. And I can count the length of AD, 1, 2, 3, 4, 5, 6. And I can know that BC is equal to AD, or that the segments are congruent to each other. And we can see that we have a set of sides that is parallel to each other because they both have a slope of 0. And we can see that that same exact pair of sides is congruent to each other because they both have a length of 6. So I'm going to add that BC equals 6 and that AD equals 6 to kind of support my conclusions here. And I would say that ABCD is a parallelogram, and I would say if one pair opposite sides congruent and parallel, then parallelogram for my reasoning. So this is like a coordinate proof. You do calculations for slope and distance and possibly midpoint, just depending on which formula you want to use, and determine if you have a parallelogram. And once you choose a method, you write that as your reason, and you have like math calculations to support it. Let's look at the next one. Here we have A, B, C, D. A is at -3, -4. I'm going to use my favorite method on this one. B is at -1, 2. C is at 7, 0. And D is at 5, -6. Now the last one was really nice because we were able to see that we had some lines that were horizontal. And that allowed me to both count the length as well as to know the slope just by looking. Here I will actually do some formulas. I mean, I did do formulas on the last one too, I just didn't have a lot of work to show. So my favorite method, which I feel has the least amount of work, is to check that if the diagonals bisect each other. And so if I'm going to check if the diagonals bisect each other, I do need to know which points are making the diagonals. And so that would be like AC and BD. So if I look at AC and I look for the midpoint, then I'm doing midpoint formula with points A and C. Sorry, my file just jumped on me. So that would be -3 plus 7 over 2. -4 plus 0 over 2. This would be 4 over 2, which is 2, and -4 over 2, which is -2. This is the midpoint for AC. Now let's look at the midpoint for BD. So the midpoint for BD using point B and point D is going to be -1 plus 5 over 2, 2 plus -6 over 2. So it's going to be 4 over 2, which is 2. 2 minus 6 is -4 over 2 is -2. And it's 2, -2. And if you're getting the same coordinate for the midpoint of both of the diagonals, that means that the diagonals bisect each other. So I can now say that ABCD is a parallelogram. And my reason would be if diagonals bisect each other, then parallelogram. So a coordinate proof is just to use your coordinates, do a math calculation, probably more than one, sometimes two like I just did here. Sometimes it takes more than that. Just depends on the method that you're choosing to use, and determine in this case if it's a parallelogram or not. We are going to go into more detail on special parallelograms and things with these coordinate style proofs tomorrow, but for today it's just determining if it's a parallelogram. And so choosing one of the 5 methods to use from this table here, whether it's doing slope 4 times to go for number 1, distance 4 times to go for number 2. On number 4, that's distance formula 2 times and slope 2 times. Or number 5 is just midpoint formula 2 times. So that's my favorite because it's the least amount of work. Let's look at some 2-column, kind of more classic proofs. Notice that there's no image given. They just tell you it's quadrilateral ABCD. What I describe for this is I tell people to draw a quad blob. It's just sort of a generic quadrilateral that could be any figure. It could be a parallelogram, could be a rectangle, could be a square, could be a rhombus, could be a trapezoid. Just draw some kind of like, sort of, that can be kind of anything, right? It could be just a very poorly drawn parallelogram. Could be a trapezoid. But we just want a generic quadrilateral that we could imagine to be any of the quadrilaterals. And we want to use this, and you want to use the name ABCD, pick one corner to start in and just go around the figure, and don't zigzag through the figure as you label it. Next, let's mark the given. They have told us that BC is congruent to AD, and they've also told us that AD is parallel to BC. Once I get those givens labeled and I kind of think about what's going on here, and I remember that today is about proving we have a parallelogram, I notice that the pair of sides that's congruent is the same pair of sides that's also parallel. And that, from my method options up here, is method number 4. So I'm able to use the given information to prove that I have a parallelogram right now. And if I have a parallelogram, then my goal is to show that B and D are congruent. And if it's a parallelogram, then that will be true. So I'm ready to get into the proof now. I'm going to start, like all our proofs, just writing down our given. We are given quad ABCD. We aren't told that it's a parallelogram. It's a general quadrilateral. We are also given that BC is congruent to AD and that AD is parallel to BC. So this is all given. That was enough to prove it's a parallelogram. So I'm going to say ABCD is parallelogram symbol. And I'm going to say if one pair, opposite sides, congruent and parallel, then parallelogram. If I have a parallelogram, then my opposite angles, B and D, are congruent to each other. So we're ready to say our goal. And I'm going to say, if parallelogram, then opposite angles congruent. So that was the property of parallelograms that we were using. So that's a pretty basic proof there. We were able to use a reason to prove we had a parallelogram, as well as using the parallelogram properties to say more information about it. Let's look at one that is a little bit more complicated. So again, we have kind of a generic quad blob going here. This one is G, H, J, K. They've given us that G and J are congruent, that H is supplementary to G. So having those add to 180. Our goal is to prove that GJ bisects HK, which if it's a parallelogram, then that would be true. What we're going to have to do to figure out if this is a parallelogram, we could prove both pairs of opposite sides parallel. We might be able to find congruent opposite angles, but I think that would be a lot harder to do. So I'm going to go for parallel lines. Keep in mind that if you have consecutive angles or same side interior angles supplementary, then you have parallel lines. So since they told us that G and H are supplementary, that allows me to know that these are parallel lines. And since G and J are congruent to each other, then we can use the congruent supplements theorem to figure out that H and J would also be adding to 180. and therefore GH and KJ would also be parallel to each other. So that's going to be my goal. So let's get started on the proof here. So we have quad GHJK. We know that angle G is congruent to angle J, and we know that angle H is supplementary to angle G. So all of that was given. If I have a pair of angles supplementary and I have a congruent pair, then I can use the congruent supplements theorem to get another pair of supplementary angles. Feels like a substitution, but it's got a specific reason that we write. I'm basically switching out the G here with the J and saying that angle H is supplementary to angle J. We're using the congruent supplements theorem to do that. And these statements will allow us to get our parallel lines. And since we're going to be using the same type of angle pair to get these parallel lines, we can write them into the same line of our proof here. So I'm going to say GK parallel to HJ, as well as GH parallel to KJ. And I'm going to say if same side interior angles congruent, then lines parallel, or the same side interior angles converse, if you want to use the title. Now that we have both pairs of opposite sides parallel, we can state that we have a parallelogram. So we can say GHJK is parallelogram if both pairs opposite sides parallel, then parallelogram. Now that we have a parallelogram, we can say that GJ and HK bisect each other because they're the diagonals of the parallelogram. So GJ bisects HK. They actually bisect each other, but yeah, one bisects the other. And we're going to say if parallelogram, then diagonals bisect each other. And so here's how we're going to be kind of incorporating proofs into this unit. They are going to be when we're talking about quadrilaterals, parallelograms, rectangles, rhombuses, squares, and sometimes trapezoids and things like that. So we are seeing proofs in this unit, but not any of the others in this semester, so at least that's nice.